Hey everyone. Today I'm going to be going over something I like to call systems thinking. Pretty much, I will add to this point over time because it's the most nebulous and the most complicated part about building anything that's worth any attention. So, systems thinking is creating multiple parts that work independently that serve a specific function. Spreadsheets and strength training are actually very useful tools in this because one, strength training is very quantifiable. There's a lot of metrics, there's a lot of specific data that you can gather. So you get the information you want, therefore you're able to get feedback, therefore you're able to grow something. And spreadsheets are really useful because though it might not seem very visual, it is a very visual medium. It takes up area, it takes up space. So you can use just regular math intelligence to figure things out, but you can also use spatial intelligence and spatial understanding and visual understanding to map out what is required for a system. So when you are given a problem, you need to give an athlete a specific number in which they had to hit during a session. Cool. Where is that number coming from? How are you generating that number? How is it being delivered? These are all questions that you ask, and you need to solve all of them appropriately in order to create a good product. Because that's what you do here. It's not just about giving them a number, it's giving them a visual representation of what you have in your brain in order to get them to fulfill that desire, really. Like, you want them to just be able to read your mind. This is just reading, right? But they also have to have buy-in. They need to know. There needs to be a no uh, difference between them what you say and what they understand, right? So designing a system is it's complicated, dude. But the thing is, no system starts complicated. They all start with a foundation of simple, unshakable, uh, let's call them modules, right? When you build any of these things, I'll even write it out as we go. The way I do it is you have a problem, right? First thing you need to do after you have a problem is define it. Like, really, like, what do you need? So that's like, define the problem. This is easy. What what information do you need? What information do you have available? So you'll see this when people build stuff. They're like, oh, we need this input data, but they can't actually get it, so they guess it, and then it doesn't actually build anything. Get the information, or whatever it is, that is required, that is quantifiable, and then make your systems upon that. So define the problem. Let's just say, what's a good example? Let's just say it's plate loading. That's pretty easy. Plate loading. You need to know what the number is that is required to put on the bar. You need to know what plates you have available, and you need to know, like, that's it. So, what information do you have available? This is actually bad. I'm just going to drop that section. Edit. So, once you have defined the problem, what information do you need? What information do you have available? Next phase is, let's say, solution. Define what your solution will be. This is super important. So once you have the problem, what does it mean to have it solved? So let's just say it's giving a weight measurement. What does that mean? Does it mean a percentage? Does it mean an actual weight? Is it being represented? Is it being a percentage of the 1RM? What is actually like a good solution? And on top of that, to make something really good, you need to consider scalable. So the easiest thing in the world would just be tell people what to weight to do on their program. Like have them in front of you and tell them, yep, 80 kilos today. But it's not scalable. So you could write it in every single time and go through every single exercise and write what they need. You don't have to be there, either do they. Also not scalable. You could put a percentage. Okay, now there's not that much interpretation. Okay, it's like you can go down the list. Like what is to solve the problem and is scalable for the solution. So, yeah, so that might be scalable and repeatable. So now we have like what is the problem? What information do we have available? What is it? Would the solution look like? And then is it scalable? Is it repeatable? So once you have those things, you can start building things. How I always, every single time I build anything, I do a basic function first. I do not build anything until I know the function I'm going to use and will it work. So do not build a table, do not build a program and then retrofit things. You need to be like, okay, it's A equals B, right? Okay, what is A? Where is A? Same things for B. What is B? Where is B? Can they go together? Once you have those questions answered, then you can do this A equals B. Always build the tiniest, simplest thing first, and then extrapolate out. Also, have siloed solutions. So, here's something I see people fuck up all the time. In their formulas, they'll be like, okay, this is the first part of the formula, and then it's embedded in the second part, and then over the whole thing, we've got the third part over here because it's timesing by that, and then we go, okay, that's. We also, there's another thing, let's divide it by a fourth part. And it's all coming together, and it's a fucking mess. The best thing to do is to go, first part, is it working? Second part, is it working? And then eventually, you'll have a point and be like, you'll do something, and it'll be like, fucking broken. So, separate your solutions into the smallest parts and then aggregate them over time. This is how you create complex systems. Think of it as you have a town. Town serves a function, right? A town isn't just built as this is town. Build all complicated components within it, make sure it works. Well, people do that, and it always shits the bed. It's actually better to have like this. We have an intention for town, but what do we need in a town? Okay, we need a hospital, police station, schools, fire departments. We need roads, and then we check, make sure all these things work together, work independently, and then we start stringing them together. And that's what creates a town. It's never like build a complicated system to begin with. Think about it as like evolution, right? We are humans. We are an incredibly complex system. But how did we start? How did evolution start? It started as like a couple of proteins in the ocean, right? And then we became into single-celled organisms, and then multi-cell organisms, and then it was like a few steps later we like created a basic invertebrate. So we had like fungi, right? And then it's like sort of squid-like, then fish, then like uh, fish, then amphibians, then reptiles, then dinosaurs. I think uh, mammals were an offspring of that. And then you've got like millions and billions of years. Then you have a human, right? Think about like any app you've ever used. First thing, it has a single Facebook, right? Connects people in Stanford to each other. Only college people. Then it's multiple colleges. Then it's everyone. Then it's where you sell things, where there's groups, where there's games, where there's I don't even know. Facebook does fucking everything now. But it started off as connect you to other people in your university. Think about that when creating systems. So define a problem, define the solution, quantify all the variables in place, create small sections in which you know they work and they're repeatable and you can see if they fuck up or not. You can see what's broken. And then over time, build, iterate, evolve big things over time. If you try and create giant spreadsheets initially, overwhelming failure. Start small, iterate, build from there. There will probably be more videos about this, but this was a good start. Thanks, guys.